The sounds of silence, a cosmic paradox. Space, the final frontier. It is a vast expanse filled with stars, planets, and galaxies. It is also incredibly silent. We often think of space as a noisy place, filled with the roar of rockets and the explosions of supernovas. But in reality, space is a vacuum, and in a vacuum, there is no sound. This seems counterintuitive. After all, space is filled with celestial objects that are constantly moving and colliding. Surely these events must create some kind of noise. But sound, as we understand it, is a vibration that travels through a medium, such as air or water. In the vacuum of space, there is no medium for sound waves to travel through. Imagine yourself floating in space, surrounded by the beauty of the cosmos. The vacuum of space, a soundless void. Sound, at its core, is a form of energy. It travels in waves created by the vibration of objects. These vibrations cause the molecules in the surrounding medium to vibrate as well, creating a chain reaction that propagates through the medium. When these vibrations reach our ears, they cause our eardrums to vibrate, which our brains interpret as sound. However, in the vacuum of space, there are no molecules to vibrate. The vast distances between celestial objects mean that space is almost entirely empty, devoid of the air and water that carry sound waves on Earth. This absence of a medium means that sound, as we know it, cannot exist in space. Think of it like throwing a pebble into a pond. The pebble creates ripples that spread outward. These ripples are like sound waves. But if there were no water in the pond, the pebble would simply sink without creating any ripples. Whispers of the giants sound on gas giants. Despite the vacuum of space, some planets in our solar system have atmospheres that can carry sound, though not in a way we would immediately recognize. The gas giants, Jupiter, Saturn, Uranus, and Neptune, are prime examples. These massive planets are shrouded in thick atmospheres composed mainly of hydrogen and helium, with traces of other gases. While these atmospheres are too thin to carry sound in the same way as Earth's atmosphere, they are dense enough to support infrasound and other low-frequency acoustic waves. These waves, below the range of human hearing, can travel vast distances through the gas giants' atmospheres, creating a deep, rumbling soundscape. On Neptune and Uranus, the presence of helium and hydrogen contributes to a fascinating acoustic phenomenon. Sound travels much faster in these gases, resulting in significantly higher-pitched sounds. Titan's Symphony, a moon's methane melody. Titan, Saturn's largest moon, is a world of stark beauty and surprising sounds. Enveloped in a dense atmosphere of nitrogen and methane, Titan is the only known moon in our solar system with a substantial atmosphere. This unique characteristic makes it a prime candidate for exploring extraterrestrial sounds. While the air pressure on Titan is only about 50% higher than Earth's, the density of its atmosphere makes it an excellent conductor of sound waves. However, the speed of sound on Titan is significantly slower than on Earth due to the lower temperature and different atmospheric composition. This means that sounds on Titan would be much lower in pitch, creating a deep, resonant soundscape. One of the most fascinating acoustic phenomena on Titan is the presence of liquid methane lakes and seas. These bodies of liquid methane, a common component of natural gas on Earth, create a unique soundscape. Section 5. Jupiter's radio roar, a storm of sound. Jupiter, the largest planet in our solar system, is a giant among giants. Its massive size and powerful magnetic field create a symphony of radio waves that have captivated astronomers for decades. These radio emissions, known as Jupiter's radio roar, are some of the most powerful in the solar system. While we cannot hear these radio waves directly, scientists can convert them into sound, revealing a cacophony of whistles, chirps, and roars. These sounds are generated by the interaction of charged particles from Jupiter's volcanic moon Io with the planet's magnetic field. Imagine a cosmic orchestra, with Jupiter's magnetic field acting as a conductor, guiding the charged particles and generating a symphony of radio waves. These waves, when converted to sound, give us an auditory glimpse into the immense power and scale of Jupiter's magnetic field. Section 6. Mars Muted Murmurs, a thin atmosphere's effect. Mars, the red planet, has long captured our imagination as a potential second home for humanity. However, its thin atmosphere, about 1% the density of Earth's, creates a significantly different acoustic environment. While sound can technically travel on Mars, it would be a very different experience than on Earth. The thin Martian atmosphere means that sound waves attenuate or weaken much faster than on Earth. This means that sounds would be much quieter on Mars, and it would be difficult to hear sounds from a distance. Imagine trying to have a conversation with someone standing just a few feet away, but their voice is barely a whisper. Another factor affecting sound on Mars is the composition of its atmosphere, which is primarily carbon dioxide. Sound travels at a different speed through carbon dioxide than it does through Earth's nitrogen-oxygen atmosphere. Section 7. Venus's bellowing thunder, a dense atmosphere's impact. Venus, often called Earth's sister planet due to their similar size and mass, possesses an atmosphere that is anything but Earth-like. Venus's atmosphere is about 90 times denser than Earth's, composed mainly of carbon dioxide with thick clouds of sulfuric acid. This incredibly dense atmosphere creates a soundscape that would be both alien and overwhelming. Sound travels much faster in Venus's dense atmosphere, resulting in significantly higher-pitched sounds. Imagine the high-pitched whine of a jet engine, but amplified and distorted by the thick atmosphere. This effect would make it difficult to determine the direction and distance of sounds. The dense atmosphere would also trap sound waves, causing them to reverberate and echo for extended periods. Imagine shouting in a large cathedral, where your voice echoes off the walls and ceilings for several seconds. Section 8. Mercury's quiet contemplation, a silent world. Mercury, the smallest and innermost planet in our solar system, is a world of extremes. It is a planet of scorching days and frigid nights, with a surface scarred by countless craters. But what about its soundscape? Is it a world of silence, or does it harbor hidden acoustic wonders? Mercury has a very thin atmosphere, almost non-existent. This means that there is no medium for sound waves to travel through, making it a seemingly silent world. However, this doesn't mean that Mercury is completely devoid of acoustic phenomena. While we cannot hear sound in the traditional sense on Mercury, scientists believe that its surface could vibrate with seismic activity. These vibrations, while too low frequency for our ears to detect, could provide valuable information about Mercury's interior structure. Section 9. Earth's auditory tapestry, a symphony of life. Our home planet, Earth, is a symphony of sound. From the crashing waves of the ocean to the rustling leaves in a forest, from the chirping of birds to the laughter of children, Earth is alive with sound. Our planet's unique atmosphere, composed mainly of nitrogen and oxygen, allows sound to travel easily, creating a rich and diverse soundscape. Earth's atmosphere is the perfect medium for sound waves. It is dense enough to carry sound effectively, yet not so dense that it distorts sounds or makes them difficult to hear. This allows for a wide range of frequencies to travel through the air, from the deep rumble of thunder to the high-pitched squeak of a bat. But Earth's soundscape is more than just the physical properties of its atmosphere. It is also shaped by life itself. The sounds of animals, from the songs of birds to the calls of whales, are an integral part of Earth's acoustic environment. Section 10. Cosmic Sounds and Our Understanding, a New Perspective. By exploring the acoustic phenomena of other planets, we gain a new perspective on the universe and our place within it. The sounds of space, while often different from what we are accustomed to, can teach us about the physics, chemistry, and even the potential for life on other worlds. The study of cosmic acoustics is still in its infancy. However, as we continue to explore our solar system and beyond, we are sure to discover even more about the hidden soundscapes of the cosmos. These discoveries will not only deepen our understanding of the universe, but also challenge our preconceived notions about the nature of sound itself. Section 11. Conclusion. A universe of sound and silence. The universe is a vast and mysterious place filled with both sound and silence. While the vacuum of space may seem like an insurmountable barrier to sound, the reality is far more complex. From the whispers of gas giants to the methane melodies of Titan, from the radio roar of Jupiter to the muted murmurs of Mars, the cosmos is alive with acoustic phenomena. By exploring these sounds, we gain a deeper understanding of the universe and our place within it. We learn about the physics of sound, the chemistry of planetary atmospheres, and the incredible diversity of worlds that exist beyond our own.